When running electrical wiring underground, such as from a panel to a well pump, the selection of the correct conduit is crucial for safety and longevity of the installation. For this type of application, Schedule 80 PVC conduit is required, instead of Schedule 40 PVC conduit. Schedule 40 conduit is generally suitable for above-ground applications where it is protected from significant external forces. However, it lacks the necessary strength and durability for direct burial in underground environments. Schedule 80 PVC conduit has a thicker wall than Schedule 40 conduit. This increased thickness provides superior mechanical protection for the electrical wires inside. When buried underground, conduit is subjected to a number of stresses, including the weight of the soil above it, potential impact from rocks or other objects in the soil, and ground movement due to freezing and thawing cycles. Schedule 80 conduit is designed to withstand these forces, preventing damage to the conduit and the wires it contains. The National Electrical Code, or NEC, sets standards for electrical installations to ensure safety. While the NEC doesn't explicitly prohibit the use of Schedule 40 in all underground applications, it emphasizes the need for sufficient mechanical protection. In most cases, the local electrical inspector will require Schedule 80 for direct burial applications due to its superior strength. Using Schedule 40 underground could lead to several problems. Firstly, the conduit could collapse under the weight of the soil, crushing the wires inside. This could cause a short circuit, posing a fire hazard or interrupting the power supply to the well pump. Secondly, the conduit could be damaged by rocks or other objects in the soil, exposing the wires to moisture and corrosion. This could also lead to electrical failures or create a dangerous shock hazard. Thirdly, ground movement could crack or break the conduit, again compromising the protection of the wires. It's also important to consider the depth at which the conduit will be buried. The NEC specifies minimum burial depths for electrical conduit depending on the voltage of the wires and the location of the installation. For example, a circuit operating at 120 volts or 240 volts, which are common voltages for well pumps, typically requires a burial depth of at least 18 inches in residential areas. However, this depth may vary depending on local codes and the specific installation conditions. Always consult with a qualified electrician and the local electrical inspector to determine the appropriate burial depth for your specific project. When installing Schedule 80 conduit, it's important to use the correct fittings and connectors. These fittings should also be Schedule 80 rated to ensure a consistent level of protection throughout the entire conduit system. PVC cement should be used to join the conduit sections and fittings, creating a watertight seal. It is very important to follow the manufacturer's instructions when using PVC cement to ensure a proper bond. Proper installation techniques are also important. The trench for the conduit should be dug to the correct depth, and the bottom of the trench should be free of rocks and other sharp objects that could damage the conduit. A layer of sand or other suitable backfill material can be placed in the bottom of the trench to provide a smooth and even surface for the conduit to rest on. Once the conduit is installed, it should be backfilled with clean soil that is free of rocks and debris. The soil should be compacted in layers to provide support for the conduit and prevent it from shifting over time. In addition to using Schedule 80 conduit, it's also important to use the correct type of wire for underground applications. Underground feeder, or UF, cable is specifically designed for direct burial and is resistant to moisture, corrosion, and other environmental factors. UF cable has a grey outer jacket, and the conductors inside are also moisture resistant. The size of the wire will depend on the amperage of the well pump motor and the distance from the electrical panel to the pump. The NEC provides tables that specify the appropriate wire size for different amperage ratings and distances. It's important to consult these tables to ensure that the wire is properly sized to handle the load. Using undersized wire can cause overheating, voltage drop, and even a fire hazard. Grounding is another critical aspect of underground wiring. The well pump motor should be properly grounded to protect against electrical shock. A grounding conductor should be run from the electrical panel to the well pump and connected to the motor's grounding terminal. The grounding conductor should be sized according to the NEC and should be green or bare copper. In some cases, it may be necessary to install a ground rod near the well pump to provide an additional grounding point. The ground rod should be driven into the ground to a depth of at least 8 feet and should be connected to the grounding conductor with a suitable clamp. Before backfilling the trench, it's a good idea to test the wiring to ensure that it is properly installed and that there are no short circuits or ground faults. A multimeter can be used to check the continuity of the conductors and the resistance to ground. If any problems are found, they should be corrected before the trench is backfilled. Once the trench is backfilled, the area should be clearly marked to indicate the location of the underground wiring. This will help prevent damage to the wiring in the future if digging or other excavation work is performed in the area. A tracer wire can also be installed alongside the conduit to make it easier to locate the wiring in the future. The tracer wire is a small gauge wire that is connected to a signal generator which can be used to trace the path of the wire underground. Finally, it's important to keep accurate records of the underground wiring installation. This includes the location of the conduit, the type and size of the wire, the burial depth, and the grounding arrangements. These records will be helpful for future maintenance and repairs. In summary, when running electrical wiring underground to a well pump, Schedule 80 PVC conduit is required to provide adequate mechanical protection for the wires. Schedule 40 conduit is not suitable for this application due to its lack of strength. Proper installation techniques, including the use of correct fittings, burial depth, and backfilling procedures, are also essential for ensuring a safe and reliable installation. UF cable should be used for underground wiring and the well pump motor should be properly grounded. Always consult with a qualified electrician and the local electrical inspector to ensure that the installation complies with all applicable codes and regulations. Remember that electrical work can be dangerous and should only be performed by qualified individuals. If you are not comfortable working with electricity, it's best to hire a licensed electrician to do the job.